Microorganism grew this from greenhouse gas, and then we push that through a high pressure filter, and then it basically leaves this stuff behind. And then once it's dried, because it's meltable, we then run it into what's called a pelletizer. So we make these long strands and we chop those up, and that creates these sort of pellets that you see here. Once you have these pellets, you can put them into sort of a traditional plastic processing piece of equipment, and you can make all kinds of shapes and parts and pieces. We call all this material, by the way, air carbon. So anything made from greenhouse gas into this molecule. So one of the things that we make is something like a fork. So this was effectively grown by microorganisms, local, these are naturally occurring microorganisms from greenhouse gas, and used to make this part that can replace what would otherwise be a plastic part.
Okay, hold on. My mind is blown. I got to ask a few more questions on this. So that fork you just held up, is that 100% biodegradable then?
Yeah, this is made, the molecule that we make is called PHB. And PHB is made throughout nature. So if this ever ends up in nature, nature sees it like a food source and completely consumes it. So another good example here. So we make straws, for instance, for Shake Shack. This is Shake Shack Green. Here's a black straw that we recently introduced. The time that it takes to degrade depends on the thickness of the part, the temperature of the overall conditions where it's landing, and then also the microbial activity. So as an example, if you have a tropical fish tank at home, you can get an air carbon straw, put it in there. It takes about 28 days to go away.
Yeah.
If you put it in a wastewater treatment anaerobic digester, 90% in about 15 days. And then if you look at, for instance, Scripps did a study on these, estimate just over a year to go away. We've also done that with Chico Research Foundation, again, just over a year. That's in colder Pacific water conditions.
Okay.
So it depends on the temperature, but it basically goes away at a very similar pace to cellulose or the components of paper.
Wow. So how many, I'm assuming this is kind of, as you think about the evolution of your company, like this is kind of still pretty early days where you're doing that. I mean, because there's so many places you could go with replacing plastics. Like, what I find really fascinating when you rewind the tape and you think about where we are as a society, there was so many benefits that kind of happened. I think plastics became more mainstream in the 60s, right? And so there's a lot of positives to that, but there's a huge, I think it's like the worst thing we've ever created as humans, because out of just most packaging is plastics within plastics. Like everything is like it's just such an abundant thing. How do you think about like where you are today and then like applying that at a much larger scale? Like, what are your biggest challenges to do that?
Yeah, it's tricky, right? Because plastics have done a lot of bad and they've done a lot of good, right?
Yeah.
Like they've downweighted so many things. And by virtue of that downweighting also saved a lot of carbon. They've created all the hygienic benefits that we often take for granted today that you wouldn't otherwise have with various other materials. And they've been low cost. So they've allowed massive economic growth. And when we all enjoy the benefits of that today. And because of that, the world uses a lot. One of the things that I've heard sometimes is, well, it's good that people are finally aware of the plastics issue and we're finally, slowing down. That is not the case at all.
No.
not only are we not slowing down or plateauing, but in fact, we're accelerating.
Yeah.
We are making more every day of plastic, and it's speeding up, not slowing down. So, kind of in line with the earlier topic that we were on, sort of like, what are these market-driven win-win solutions? If the world is going to use materials, what if you could harness those pathways, as a way for positive change? In other words, if plastic, instead of emitting 2 or 3 times its own weight in carbon as a function of production, what if plastic as a conveyor belt was actually reversing the flow of carbon?
Yeah.
Every time you used a fork or sunglasses, so this, for instance, my sunglasses, these are made from air carbon. What if these products were part of a way to reduce or reverse the flow of carbon? And so that's where I think we can harness the world's massive usage of this material class, but do it with a slightly different material that provides the same functionality, but does it but because it's made from greenhouse gas capture, it has a totally different impact. So I don't think we're going to change the world's like utilization of this material class.
Yeah.
But if we can actually turn what is a very challenging thing, to your point, into let's use this as a tool. I always like to think of it as like this conveyor belt. It's coming up on 1 trillion pounds per year.
Yeah.
What if that were made from greenhouse gas? Like that's a totally different paradigm.